So if I've got two fractions, for example, I've got 3 by 5 plus 4 by 5. So I write over here 3 over 5 plus 4 over 5. This fraction, obviously for fractions you would say that sir, we can solve them in the calculators and that's how we would be usually getting our answers. My reply to that would be learn to handle fractions. Anything that you can do verbally, it would save time on the exam, and the more time you save on the exam, the quicker you would be able to complete the paper and you would have more time to recheck your answers, and chances of scoring better marks are higher. Okay, so fractions, they can be added straight away if the denominators are the same. So 3 by 5 plus 4 by 5, I would simply add their numerators. It would become 7 by 5. Simple. But what if the denominators of the fractions, they are not the same? So for example, one of them it says 3 by 5 and the other of them it says plus 4 by 9. Now what we'll have to do is we'll have to make the denominators the same. Okay, how do I make the denominators the same? Is there a number that I can multiply any of the fractions with? So that would make the denominators the same. First thing, I'll check that. For example, over here, I cannot do that. There isn't a number that I multiply with 5 that would make it 9. Similarly, there isn't a number that I multiply with 9 that would make it 5. So what I will do is, for both fractions also, what I know is that each of them I can multiply them with 1 and it wouldn't make a difference, right? So instead of 1, what I'm going to do, the second one I'm going to multiply and divide with 5. So I'm multiplying the second one with 5 over 5, and I will multiply and divide the first one with 9 over 9. So that way their denominators, now both of them, they would have 45 in their denominator. So the answer for this would be 9 3s are 27. So 27 by 45 plus 4 5s are 20, 20 by 45. And now as the denominators are the same, I can add their numerators. So it would become 27 plus 20, 47 by 45. And this is an improper fraction. I can convert it into a compound fraction. That would become 1 whole 2 by 45. Right? Okay. The other thing, so this is example number 1 over here. Example number 1. This is case number 2 or example number 2 over here. The third thing that we can see, so for example, let's say the number that I have to add is 3 over 5 plus 8 over 15. Here I can see that one of the fractions in its denominator, the number is 15, and as for the other one, the number in its denominator is 5. So can I multiply one of the two fractions with a particular number that would make the denominators of both of them same? Yes. For the first one, I can do that. So for example, for this 5, if I multiply it with 3, but I cannot simply multiply a number. The only number I can multiply any fraction with without any consequences, that is 1. So if I'm multiplying the denominator with 3, I'll have to multiply the numerator with 3 as well. So that way, this would give me, for the first fraction, 3 3s are 9, 9 by 15. The second one, it stays the same, 8 by 15. And now I can add the two fractions, 9 plus 8, that would give me 17 by 15. And 17 by 15, the final answer would be 1 whole 2 by 15, right? So this rule that the denominators of the fractions, they have to be the same, it applies to addition and subtraction only. If we are doing the multiplication or division, this rule wouldn't apply. So for example, the same fraction, the two fractions where denominators didn't match, I had 3 over 5 plus 4 by 9, question number 2. So I'm making a modification to question number 2. Previously I had 3 by 5 plus 4 over 9. Now I'm saying 3 by 5 times 4 by 9. So what do I do now? Do I make the denominators the same? There is no need. Numerator will multiply with the numerator, denominator multiplies with the denominator. Answer would be simply 12 by 45. Okay. Similarly, for the third question that we had the first fraction 3 over 5 and the second fraction was 8 by 15. If I'm multiplying the two fractions, there is no need to make denominators the same. I'll simply multiply numerator with numerator and denominator with denominator. So in the denominator, I'll have 75 and 3 8s are 24. I'll have 24 in the numerator. Any questions this far? Okay. Another thing, the rules for addition and subtraction are the same. The rules for multiplication and division are the same. That is, either if I'm adding a particular number in either I'm adding one fraction into another or subtracting one fraction from another. In both cases, denominators, they have to be the same. Similarly, if I'm multiplying the two fractions or dividing the two fractions, then the denominators, they do not have to be the same. Okay, let's take a few examples for that as well. And let's see. So for example, the first one, I had 3 by 5 plus 4 by 5. So if I write over here, the next question, what number would it be? Question number 6 or case number 6. Okay, so I've got 4 by 5 minus 3 by 5. Denominators are the same. I'll have the common denominator, and 4 minus 3, answer would be 1 over 5. For the second one that I had, 4 by 9 and 3 by 5, if I say, for example, 3 over 5 minus 4 over 9. Okay, what do I do now? Are denominators the same? No, I'll have to make denominators the same. How do I do that? In this case, I'll have to multiply and divide the second fraction with 5 and multiply and divide the first fraction with 9. So that would give me 9 3 is 27. So 27 by 45 minus 20 by 45. 27 by 45 minus 20 by 45 and 27 minus 20. I know the answer would be denominators are the same. Now I can do the subtraction in the numerator. 27 minus 20 would be 7 over 45. All four of you, any questions at all in this thing? If you're staying silent, I'm assuming that you all are understanding this thing. And if I give you a question, you would be able to solve that on your own. Miss Anam. Which one? 3 by 5? Because I have to make denominators the same. In one of the denominators, I had 5. For the other fraction in the denominator, there was 9. So if I'm multiplying 9 with 5 in order to make it 45, I'll have to multiply 5 with 9 to make it 45. Okay, so how do I see? First of all, I see, is there any number for which I'll have to multiply just one fraction with that number, and it would therefore there wouldn't be any need to multiply the second fraction with that number. Can I multiply 9 with anything that would give me 5? No. Can I multiply 5 with anything that would make it 9? No, I mean there would be decimal numbers, but I'm talking about whole numbers right now. So if such numbers do not exist, then what I do is I take this number, the denominator of first fraction, and multiply and divide the second one with this, and then I take the denominator of second fraction and multiply and divide the first one with this. That way in denominators both would have 9 times 5, and that would make denominators the same. Okay. All right. Similarly, for question number next, so we have solved 6. Let's do another one. 7. 7 says 3 by 5 minus 8 by 15. So 3 by 5 minus 8 by 15. I know right now denominators are not the same, But for the first one, the first denominator, if I multiply it with 3, that would make denominators for both the fractions the same. So I cannot simply multiply the denominator. I'll have to multiply numerator and denominator. So that would make it 9 by 15 minus 8 by 15, which would make it equal to 1 by 15, right? And as for the division, let's take a few examples for division as well. If I have got 3 by 5 divided by 4 by 9, okay, the first step would be to convert this division sign into multiplication. So when I convert this division sign into multiplication, the fraction after it flips. So 3 by 5 divide, if I change it into multiply, it would become 9 by 4. Okay, and this would give me no numbers, they cancel each other out, so this would simply give me 27 by 20, or 1 whole 7 by 20. All right, so let me give you a few questions that you people can do. And obviously if I've got more than two fractions, okay, let's do a few questions for three fractions as well. So for example, I have this question over here which says 3 by 13 plus 1 over 4 plus 1 over 2. Mr. Arman, can you tell me how should I go about solving this question? Yes, please. Hmm. If the denominators are not the same, we cannot add the numerators. We can get the LCM, but the quicker way would be, so for example, if we see the last two fractions, it is relatively easy to make their denominators the same. How? I simply multiply the last one with 2 over 2, right? So the first fraction, it stays the same for now, it stays 3 by 13. The second fraction, it also stays the same, 1 by 4. The last fraction, it becomes 2 by 4. Now for the last two fractions, denominator is the same, so I can add them. If I add the last two fractions, the first one stays the same, 3 by 13. And for the other two, 1 by 4 plus 2 by 4, it would become 3 by 4. Okay. And now I've got only two fractions. For these two, I have to make denominators the same. So I cannot multiply one of them with any number that would make denominators the same. So what I'll do is I'll multiply and divide the second one with 13 and the first one with 4, 4 by 4. Okay. So that gives me, sir, 4 threes are 12 and 13. 13 twos are 26, 52. 52 plus 13 threes are 39 and 52. So now their denominators, they are the same. And now I can add the two fractions. So this would give me 52 in the denominator and 51 by 52. Any confusion if any one of you have in this class? Why are all your cameras turned off? Anam, Arman. Hmm. Okay. So if you understand this, then I've got, Shailen, let me help you with one more questions. Then I'll give you a few that you can solve. Let's say if I've got two fractions or three fractions, and some of them are adding and some of them are subtracting. So for example, let's say we have which question would this be? Question number 10. Okay, we have 4 by 5 minus 3 by 10 plus 7 by 20. Miss Noor, how do I solve this one? What's the first thing that I should do to solve this part? So first two fractions that we would handle are this and this. Okay, so 4 by 5 stays the same. 4 by 5 stays the same. For the minus 3 by 10, can I multiply and divide it with certain number so the denominator becomes 20? Yes, I'll multiply and divide this one with 2. 2 over 2. Okay, so 4 over 5 stays the same. 4 over 5. Okay, it becomes minus 3 by 20 and minus 6 by 20 plus 7 by 20. And then this would become 4 by 5. Here 20 is the same, minus 6 plus 7. So minus 6 plus 7 would be 1. So it would become 4 by 5 plus 1 over 20. And now I have to make the first fraction. I need to get 20 in its denominator. So what I'll do is I'll multiply and divide with 4. Okay, so that gives me 16 by 20 plus 1 over 20, and the answer would be 17 by 20. If you people want to do this 4 by 5 and 7 plus 7 by 20 addition first, what would that become? I'd be rearranging a bit, so it becomes 4 by 5 plus 7 by 20 minus 3 by 10, right? So if I do that, the first fraction I'll have to multiply and divide with 4. So I multiply and divide with 4 so that the denominator becomes 20. So it becomes 16 by 20 plus 7 by 20 minus 3 by 10 stays the same. So 16 plus 7 is how much? 23 by 20 minus 3 by 10. Then I'll have to multiply, divide this 3 by 10 with 2. So that gives me 23 by 20 minus 6 by 20. So 23 minus 6 would be again 17 by 20. So whichever method you follow, as long as you're doing the maths right, your answers, they should be the same. I'm writing a few fractions over here. I wonder if we would have time for recurring decimals today. Anyhow, this is important. So let's spend some time on this. So the ones that you would do are, let's see. Let's just practice fractions today. These are the ones that you have to solve, and as soon as you get your answers, let me rename the questions. So this is, let's call it question 11, question 12, question 13, question 14, and question 15. Please go ahead, quickly solve these 5 questions and give me your answers. Isnor, are you there? Sure, sir. Go ahead. 1 over 8 is not correct. Anyone else? 3 over 54. 3 over 54. 3 over 54 can be reduced further. Miss Noor? It is 1 over 18. 3 over 54, it will be reduced further to 3 over 18. 3 can. Hmm. Hmm. All right, Arman. 1 over 18. Question number 11, answer is 1 by 18. Arman, as soon as you have done question 12, can you send me a picture of your solution for that? Okay, Miss Noor and Mr. Arman both have the answer for question 12. Question number 12. Can you both type it in the meeting chat? Your answers. 31 out of 10, Arman? Hmm. Are you connected to the uh, mixed fraction? No, you should write 3 whole 1 by 10. Good, good. Arman, you got the same answer? Acha ji, for the second one, Miss Noor and Sir Arman, they are saying it is 3 whole 1 by 10. Okay ji, have you solved question number 13 as well? Did all of you get 9? This would be 9 by 9, so this would be 36. 36. This would be 36. Did all of you get 25 by 36 for question number 13? Anybody who didn't get that? 25 by 36. All of you got that, right? Okay. Let's see, where do this pudung come from? Yes, madam. 117 minus 92 is how much? 117 minus 92, that's 25. It's supposed to be 25 by 36. See, first of all, I convert them into compound fractions into improper fractions. So I get 13 by 4 and 23 by 9. I can't add them, denominator is different. So I multiply the second fraction with 4 by 4 and the first one with 9 by 9. So for the first fraction, I get 117 by 36. For the second one, I get minus 92 by 36, right? And then now denominators are the same, so I write 36 in the denominator. 117 minus 92, that would be 25, not 125. Okay. 125 by 36, no. 117 minus 92, that simply gives me 25. 1 whole 25 by 36 I'd only get in case I'm getting an improper fraction, and then I convert that into a compound fraction. Here I'm not getting any improper fraction. Okay. Because over here numerator is smaller than denominator. When numerator is smaller than denominator, there is no need to convert. Improper fraction is the one in which, so for example, why is that called improper fraction? Another question, let's clear that thing. If I say 5 out of 7, what does 5 out of 7 mean? 5 out of 7 means there are 7 things, and out of those I'm choosing 5, right? 5 out of 7, there are 7 things, out of that I choose 5. If I say 7 out of 5, how can I choose 7 out of 5? If there are 5 things, how am I choosing 7? So that is why this needs to be converted, and the first one doesn't need to be converted. It's fine as it is. That is why this is proper fraction and this is improper. And the improper one, it gets converted. So 7 by 5, it would mean there is one whole and then there are 2 out of 5. There is one complete thing and 2 out of 5 of the second thing. So that addresses the question why first of all we convert the improper fraction and not the proper ones, and what is an improper fraction and what is a proper fraction. That too. Okay, Ji. Let's now quickly look at question number 14. 4 twos are 8, 1, 9 by 2. Then minus 5, 1, 5 by 4. 5 by 4 minus 29 by 8. Did you all get these fractions, or did anybody get a different answer till this step? For which fraction? Oh, okay. First of all, this is the complete question. So even when we are solving parts of it, we would keep writing the rest of the parts. That was a problem in your previous solution as well. You had written, I mean, you solved them in parts, and when you were solving them in parts, you weren't mentioning the rest of the parts. See, this is what is given, and whatever we write next, it should be equal to the thing written before it. So even when I'm solving in parts, I'll just write all of it down and not ignore anything. The things that I'm not solving, I'll just copy them as it is. Now, for this fraction, 4 ones are 4, 4 plus 1, 5. So the second fraction, it would convert it to minus 5 by 4, right? And the last one, 8 threes are 24, 24 plus 5, 29. So it would be minus 29 by 8, the last one. Is there any confusion in this first step? This is step number 1. Any confusion in this? Anybody? No. Okay, let me move to the next step. What I would do is I'd multiply and divide the first fraction with 2 so that its denominator it becomes 4. So it becomes 18 by 4 minus 5 by 4. And since denominator is the same for both of them, it would be 4, and 18 minus 5, that would be 13 by 4. And this one, it would be 29 by 8. It stays as it is. Any confusion in step number 2? Miss Anam, do you understand till step number 2? Miss Noor, do you understand till step number 2? Which step? 1 or 2? So what I did was, did you understand step number 1? The three fractions that I got. 9 by 2. No, 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 no. It shouldn't be kind of. It should be everything. Why don't you people wait for me to ask and not tell me yourself if you haven't understand anything? Okay. Look over here. Look over here. This is 4 whole 1 by 2. It becomes 9 over 2. Any confusion? 2 2 fours are 8. 8 plus 1, and then we add the numerator, so it becomes 9 by 2, right? Then this 1 whole 1 over 4, it becomes minus 5 by 4. How? 4 ones are 4. 4 plus 1, 5. So it becomes minus 5 by 4. For the last one, 3 eights are 24. 24 plus 5, 29. So it becomes 29 by 8. Okay. Now the next step is that I have to start adding the fractions now. So what do? I take the first two, 9 by 2 and minus 5 by 4. In order to make their denominators the same, I will multiply and divide the first one with just 2. So the first one, it becomes 18 by 4. The second one is minus 5 by 4. The third one is it would be 29 by 8. Got it? Now if I solve just the first two, 18 minus 5, that would be 13 by 4. And this minus 29 by 8, it stays the same. Okay. And now in order to make the two fractions the same, I'll have to multiply and divide the first one with 2 so that its denominator it becomes 8. It will become 13 2s are 26 over 4 2s are 8. 26 over 8 minus 29 over 8. And this becomes minus 3 by 8. So Arman, were you saying minus 3 by 8? Were you saying minus 3 by 8 for this one? Okay, minus 3 by 8 is the answer. I'm sorry if I said that was wrong. Minus 3 by 8 is the answer for this one. Do all of you understand this now? Miss Anam? All right, quickly answer for the last question, part F. Let's solve this together. Acha ji. 4 24s are 80, so the first fraction it becomes 87 by 20. Am I right? The second one becomes 10 plus 1 11, 11 by 2. And the third one it becomes 5 to the 10, 10 plus 2. 10 plus 2 would be 12 by 5, right? All right. So which two do we do first? This and this. Okay. So in order to solve these two, I'll have to multiply and divide this one with 5, right? Sorry, again. So you added these two first. Mm, this and this, right? No problem. So in order to do that, what do I do? I'll multiply and divide this one with 2 and the one before it with 5, right? 5 by 5 multiply. Okay, so 87 by 20 stays the same. It becomes minus 55 by 10. 24 by 10. Okay, so I say 87 by 20 stays the same. Here I've got 10 and minus 55 plus 24. So that would be 24 minus 55, which is equal to 87 by 20 and minus 31 by 10, you say? 31 by 10. Now I multiply, divide this with 2 so that the denominator becomes the same as the first one. So this would become 87 by 20 minus 62 by 20. So 87 minus 62 is how much? What's minus 55? You have access to the board. I had sent you the link on Gmail. So 87 minus 62 is 55, right? So I simply 62 is minus. So I don't get your confusion. It is not. It is not 55 by 20. It would be 25 by 20. By the way, 87 minus 62 would be 25, not 55. Oh, okay. 25 by 20. So this would give me 5 by 4 or 1 whole 1 by 4. Miss Anam and Miss Noor, did you also get this answer? Sure, sir, you can. One whole 1 by 4. Is that your answer? How did I get 1 whole 1 by 4? So 5 by 4 is an improper fraction, and improper fraction have to convert it into a compound one. So I say 4 is how many times 5? I mean 5, if I divide it over 4, the nearest I can get is 1. 4 ones are 4. So I write 1 whole, and 4 ones are 4. So if I take 4 out of it, what remains is 1. Do you know how to convert improper fractions into compound fractions? Do you know how to do that? No. Okay. Here is how we do that. Let's say I have got 7 out of 5. Okay. So first thing I would say is 5, how many times 7? 7 doesn't come in the table of 5. So what comes is 5 itself. How many times? If I multiply 5 with 1, then it would be 5 itself, right? So I write 1 whole, and if I multiply 5 with 1, I get 5. What remains out of 7? 2. And denominator stays the same. The other way to do that is you put 7 inside and you try to divide. So you say 5 ones are 5. You would have 5 over here, and you will have 2 remainder, right? So this over here, this is the quotient. This becomes this number. Remainder becomes this number, and denominator, it stays the same. It is this same old 5. Got it? So how did I do it for 5 over 4? I said 5, and then outside I had 4. So I said 4, how many times 5? 4 ones are 4. Remainder is 1. So this is quotient. I write 1 whole. This is remainder. It comes in numerator 1, and this is denominator. So it becomes 1 whole 1 by 4. Do you understand now how to convert improper fractions into compound fractions? So Miss Anam, for you, homework would be, I'm giving you a few improper fractions, and you would give me their compound fractions tomorrow. 99 by 98. Note them down. 99 by 98. Then you have um, 25 over 19. Okay. And you would have 8 over 3. For these three fractions, improper, are they improper fractions or not? These three, they are improper fractions. How do we know? Denominator is less than numerator, so these are improper fractions. Miss Noor and Miss Anam, you would give me answers of these improper fractions converted into compound fractions tomorrow. This is additional homework for the two of you. Miss Noor, do you get it? So these are three improper fractions, right? I'm simply asking for mixed fraction or compound fraction for these three. So if you have 99 by 98, how do you make mixed fraction out of it? What would be the answer of this one? I just told you how we convert improper fractions into compound fractions. Didn't you listen? This is when I was telling you. Okay. So for the first one, I would solve it for you and I'd give you another one in its place. So if I divide 99 over 98, so 99 is inside, I have 98. 98, how many times 99? What's the closest I can get? Miss Anam? 1. So 98 ones are how much? 98. And the remainder would be 1. So this is quotient. So 1 whole 1 over 99, 98. Excellent. And this one is remainder, and this one over here is quotient. Okay. So for example, let's do these three right now and give you some more for homework. If I have 25 by 19, so I write 19 outside, 25 inside, like this. 19, how many times 25? Ones are 19 twos are 38. So that would exceed. So 19 ones are 19, right? 6 would be the remainder. 6 would be the remainder. So 25 minus 19, it would be 6 over here. So its compound fraction would be 1 whole 6, 6 over 19. Do you understand it now? Okay, so now the three fractions that you have to do as homework are 55 over 2, question 1. 55 over 2. Question number 2. 75 over 71. And question number 3. 100 divided by 27. Okay, these three questions are your homework. You have to convert these improper fractions into compound fractions. Is it clear now?